Okay, number 8 says find the zeros of the function by factoring and then sketch a graph of the parabola. So again, if we're finding the zeros, that means we want to set f of x equal to 0. So here I'd have 0 equals x squared minus 9. Now, I can just add 9 to both sides and take the square root because I don't have that middle term in my trinomial. So if I add 9 to both sides, I get 9 equals x squared. Take the square root of both sides. X is going to equal plus or minus 3. So that means my two zeros are going to be 3 and negative 3. So I go over to my graph, 3 on the x-axis and negative 3 on the x-axis. Again, I'm just looking for a general sketch here. Since A here is a positive 1, then that means my parabola opens up. So as long as you've got the x-intercepts and you give me some sort of U-shaped curve that's in the right direction, you're going to be okay. 9, we want to solve. If I can get it to focus. 9, we want to solve using the quadratic formula. If necessary, show solutions in imaginary form. So again, quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I'd have negative b is negative 4 plus or minus the square root of, again, b is negative 4 squared minus 4, a is 3, c is 5, over 2 times a is 3. So if I begin to work that out, the opposite of negative 4 is positive 4, plus or minus. Negative 4 squared is 16. Negative 4 times 3 is negative 12. Negative 12 times 5 is negative 60. If I add those two together, 16 and negative 60, I get negative 44. And on bottom, 2 times 3 is 6. And again, if this is not a perfect square, in this case it's a negative, which we can't even do, it means we have no real solutions. But if it's not a perfect square, we're just going to leave it in that form. Okay, number 10, complex operations. So again, we're using I, and again, the key thing to remember about that is I squared equals negative 1. But the first part, we're just subtracting two complex numbers. So we got 7 minus negative 2, so minus and negative makes that plus 2. So 7 plus 2 is 9. Here we've got negative 2i minus negative 4i. So again, minus a negative makes that a positive 4i. So negative 2i plus 4i is positive 2i. Part B, we're multiplying complex numbers together. So again, we can use the box or FOIL or whatever you want to use. So I got 5, negative 3i, 2, and I. So 5 times 2 is 10, 5 times I is 5i, negative 3i times 2 is negative 6i, and negative 3i times I is negative 3i squared. Now, since I squared is negative 1, this means negative 1 times negative 3 is a positive 3. So when I combine my like terms, I can add 10 and 3 together to get 13. Negative 6i and 5i is just negative 1i. So 13 minus I. Now when we're dividing complex numbers, we don't want to have an I in the denominator, so we got to multiply by the conjugate. And again, the conjugate is just changing the sign on the number in the bottom. So instead of 3 minus I, 3 plus I. And I got to multiply the top and bottom by that. So I'm going to have to do the Punnett square twice or FOIL twice. So if I do the top, I'd have 1 plus 2i 3 plus I. And then the bottom down here have 3 minus I and 3 plus I, or positive I. So here 1 times 3 is 3, 1 times I is I, 3 times 2I is 6I, and 2I times I is 2I squared, but again I squared is negative 1, so it'd be negative 1 times 2, which is negative 2. So if I work that out, 3 and negative 2 is 1, 6I and I is 7I, so 1 plus 7I. And if you remember, that was our top part of our fraction. So I got 1 plus 7I. The bottom part, 3 times 3 is 9, 3 times I is 3I, 3 times negative I is negative 3I, and then I have negative I squared. But again, I squared is negative 1, so it's negative times a negative 1, which is a positive 1. Here the 3I and negative 3I would drop out, and then 9 plus 1 is 10. So I'd have 1 plus 7I over 10.